A 4 kilo point mass is dropped such that it travels vertically, okay? And there's a vertical resistance equal to 20% of the mass's velocity in regards to its motion. So it resists or opposes motion. Find the object's velocity with respect to time. Right, time to break it down. So we've got rectilinear motion, so it's one-dimensional, okay? It's up and down. I'm going to choose positive in the down sense, all right? And we've got basically a resistance to motion I'm going to call R, and we've got information about R. R is 20%, so R is 0.2 V, okay? It's in regards to the velocity, all right? And we've got to consider also the weight, okay? So we've got weight going down, and weight is mg from our previous work. In this case, weight will be 4g because the mass is 4. Okay, what else do we need to look at here? So it's basically 0.2. We could call that R equals 1/5 V if you prefer to work in fractions. Of course, that's a minor point there. And we don't need any vector notation because this is rectilinear motion, okay? So basically, I think we've broken this down pretty well, and we're ready to look at solving it now. And yeah, basically, we've got it forced down due to weight, and we've got an opposing air resistance or something in the medium. Okay, so now we're going to go ahead and we're going to solve it, and integration will be used along the way. Okay, so let's solve it. Solving. So Newton's second law, F equals ma, is our starting point for the full solution, and we've got ma equals mg minus kv as per our model. Substituting some of those values in where mass is 4, and then dividing through by 4, we have A equals G take V on 20 in fractional form. Now, key point there is that we have to choose our expression for acceleration, which is dv dt. And we have a variable acceleration. And so we have to collect a group and simplify, and then choose the appropriate term from your formula sheet. Okay, there are other ones, but this one is the suitable one for us, as we shall see. So once we do that, we can get ready for the separation of variables. So we have dv equals g minus v on 20. And on the right-hand side, we have 1 dt. Getting ready for integration. We need to be in the form of generically this. Okay, we're integrating in terms of v, but it's that form, and that becomes natural log of the denominator function generically, okay? More specifically, however, now we have negative v on 20 plus g on the bottom, so we need negative 1/20th on the top. We need to counteract that. So that says negative 120 dv. We have to counteract that by the reciprocal. Best place to put it is outside, so that's negative 20 times that integral there with regards to v, and we integrate 1 dt. So if we look over here, it continues on, and then we have negative 20 natural log g take v over 20 equals t. We bundle the constant from both sides together, and we put that there. Okay, so moving ahead, dividing by negative 20, Notice how we're using index law number 1 here as we move through, and we have two separate parts of the product there, both of base E. Now, what we need to consider is this value of A, which is an arbitrary constant, okay? And we need to go back and initially, so in other words, what I mean is where A equals this here is A is being replaced by that, okay? Is what we mean there. So we're just bundling that together because that is a constant there. All right, this here is a constant. We're just bundling it together as an A, which makes it a bit more compact. Initial conditions. So initially, velocity is 0. So t equals 0, v equals 0. That, you'll see, gives us g equals a e to the power 0. So a is actually g, which is a constant. Okay, so going back now and subbing in okay, we have g take away v on 20 equals g times e to the negative t over 20. Rearranging and multiplying through by -1, we get v over 20 equals g take away g e to the negative t on 20, and multiplying through by 20 and taking a factor of g out, 1 minus e to the negative t over 20 inside the brackets there. And let's check through that we've got everything under control there. We needed to find a v of t function, and we used integration, and we have a function in terms of both t and v satisfying the conditions of the question. See you in the next video.